Something happened in the winter of 1890 that nobody could explain. In a small village on the edge of Siberia, horses started dying. Not slowly, not from starvation. They collapsed mid-stride, in the middle of fields that had fed livestock for generations. Within days, the people who handled the bodies started getting sick too. Fever, skin that turned black, then they died. The local authorities wrote it off as a bad season, contaminated water, maybe, harsh weather. The kind of explanation you give when you don't have a real one. But here's the thing, that exact pattern, animals first, then humans, then silence, has shown up again and again throughout history. Different continents, different centuries, different names, and for a long time nobody connected the dots. I did. And what I found after going through outbreak records, declassified Soviet medical reports and papers that most people never read, is that we may have been living alongside escaped ancient pathogens for longer than anyone officially admits. And the scientists who thawed a 48,000-year-old virus in 2023, they weren't the first to wake something up, they were just the first to do it on purpose. Stick with me, because this goes places the news cycle never touched. Before we get into the evidence, you need to understand one thing about how disease outbreaks work. When a new pathogen appears, the first question epidemiologists ask is, where did it come from? And the answer is almost always one of three things. It jumped from an animal, it mutated from something we already knew, or it came from a reservoir. The thing about reservoirs is that we've always assumed they're recent. A bat cave in China, a wet market, a pig farm in Southeast Asia. What nobody seriously considered until very recently is that the largest reservoir on the planet has been frozen for tens of thousands of years, and it's been thawing for the last century. The permafrost, that layer of permanently frozen ground that covers about a quarter of the northern hemisphere. Siberia, Alaska, northern Canada, Greenland. For most of human history, it stayed frozen, it stayed sealed. Whatever was locked inside it stayed locked. But the ground has been warming, slowly at first, then faster. And as it thaws, it doesn't just release water, it releases everything that was preserved inside it. Mammoth bones, ancient plants, carbon that's been sequestered since the last ice age, and microorganisms, bacteria, spores, viruses, some of them tens of thousands of years old, some of them still capable of infecting living hosts. That last part is not speculation. That's peer-reviewed science. What I want you to think about first is a question that kept me up the night I started putting this together. If ancient pathogens can survive in permafrost, and the permafrost has been thawing for over 100 years, and we've had unexplained disease outbreaks for over 100 years, is it possible that some of what we called new diseases were never new at all? Is it possible they were old, ancient even, just waiting for the ground to soften enough to let them out? Let's look at the first piece of evidence. The year is 1918. The First World War is winding down. Soldiers are coming home from the trenches, and something is traveling with them. Not in their luggage, not in their wounds, in their lungs. The 1918 influenza pandemic, the one history calls the Spanish flu, even though it almost certainly didn't start in Spain, killed somewhere between 50 and 100 million people, more than the war itself. It moved faster than any disease outbreak in recorded history. And for decades, the scientific community had one clean explanation. It was an avian flu that mutated and jumped to humans. Novel, spontaneous, a freak of viral evolution. Except the origin of that virus has never been conclusively proven. The Spanish flu label was a media artifact. Spain was one of the few countries not censoring its press during the war, so when the outbreak hit Madrid, it was reported openly. Every other major nation was suppressing the news to maintain morale, so Spain got the name, even though the first confirmed clusters appeared in military camps in Kansas in the spring of 1918, months earlier. But even Kansas raises questions, because soldiers in those camps had been shipping through ports and transit points that connected to one specific geography, the northern supply routes, the routes that ran through Alaska and the Alaskan interior, where the ground was, and still is, permafrost. In 1997, a researcher named Johan Holten traveled to a remote Alaskan village called Brevig Mission. In 1918, that village lost 72 of its 80 residents to the flu in less than a week. The bodies were buried in the permafrost, which preserved them almost perfectly. Holten recovered lung tissue from a woman who had been in the ground for 79 years. The 1918 virus was still intact inside her lungs, still reconstructible. A virus that had been frozen in the ground for nearly 80 years was not only preserved, it was recoverable. Let that land for a second. Scientists were able to reconstruct it, sequence it, study it. Now, I'm not saying the 1918 flu escaped from permafrost. The official origin remains debated, and I'm not here to push a conspiracy. What I'm saying is this: the evidence that the 1918 virus survived in frozen ground for 80 years is not a theory. It's a documented scientific fact. And if a virus can survive 80 years in frozen ground, the obvious next question is, what survived longer? That brings me to the second piece of evidence, and this one gets darker. The Soviet Union had a complicated relationship with the truth. One area where Soviet secrecy has had lasting consequences is in the documentation of disease outbreaks across Siberia and the Russian far north. Between the 1950s and the 1980s, there were multiple anthrax outbreaks in Siberia that were officially attributed to improper livestock management, bad hygiene, infected feed. The same explanations you always get when the real explanation is uncomfortable. But anthrax is a fascinating pathogen for our purposes because Bacillus anthracis forms spores, and those spores are extraordinarily resistant. They can survive in soil for decades, possibly longer, and they remain infectious. Here's what we know happened in 2016. On the Yamal Peninsula in Siberia, after an unusually warm summer, the permafrost thawed more than it had in decades, and something underneath it was exposed. An anthrax outbreak followed. Over 2,300 reindeer died. Dozens of people were hospitalized. A 12-year-old boy died. The source was traced to an old reindeer carcass, an animal that had died of anthrax 75 years earlier and had been frozen in the permafrost ever since. The warming ground released it. The spores were still active, still lethal, after 3/4 of a century in the ice. Now think about what else is in that ice. The Soviet Union conducted extensive biological weapons research through the Cold War, much of it in facilities in the Russian north. Some of that research involved pathogens that were deliberately engineered to be more resistant, more virulent, more persistent. And some of those facilities are in regions where permafrost is now thawing. The ground across the northern quarter of the planet has been acting as a deep freezer for biological material, natural and otherwise, for thousands of years. And that freezer is defrosting. And we've been watching the consequences of that in slow motion without recognizing them for what they are. If you're watching this and you haven't subscribed yet, now's a good time. Because what comes next is where the individual cases start connecting into something that's very hard to dismiss. The third piece of evidence doesn't come from a history book, it comes from the last 10 years. In 2014, French and Russian researchers working in the Siberian permafrost isolated a virus they called Pathovirus sibericum. It was roughly 30,000 years old. And when they exposed it to amoeba cells in a controlled laboratory setting, it infected them. It woke up. Read that again, because the scientific community buried the lead on this one. A virus that had been frozen in the ground since before modern humans reached Europe became infectious again after thawing. Not theoretically, not in simulation, actually infectious, actively replicating. The researchers were careful to note that this particular virus only infects amoeba and poses no direct threat to humans, and that's true as far as we know. But here's what they also noted, in language that was much quieter than the press release. They don't know how many other viruses from the same sample site remain untested. They don't know what else is in that permafrost layer. They explicitly acknowledged that the principal ancient viruses surviving in permafrost and retaining infectious potential is now established science, not hypothesis. In 2023, the same team published results on 13 additional ancient viruses recovered from Siberian permafrost samples. The oldest was approximately 48,500 years old. All 13 were still capable of infecting host cells in laboratory conditions. 13 viruses, still active. And the thing that barely made the news is this. Those 13 viruses were from a single research dig in one location over one season. The permafrost that contains them stretches across millions of square kilometers. Nobody has sampled most of it. Nobody knows what's there. Let me give you a sense of scale. The permafrost in Siberia alone covers approximately 10 million square kilometers. The depth of some of these frozen layers extends over a kilometer underground. Researchers have estimated that a single gram of permafrost soil can contain up to 1 billion viral particles, most of them unidentified, most of them unstudied. All of them in the warming regions, gradually getting closer to the surface. The modern framework for understanding pandemics assumes that novel pathogens come from one of a few known sources. The entire infrastructure of global health, the surveillance systems, the rapid response teams, the modeling frameworks is built around those assumptions. None of it is designed to look backward. None of it is systematically monitoring what's emerging from the permafrost. There is no global early warning system for ancient pathogen release. There is no protocol for what to do when something comes up from the ground that has no match in any existing database. Think about what that means in practical terms. If a virus escapes from permafrost and starts circulating, the first thing epidemiologists will do is try to identify it. They'll run it against every known pathogen database. For a truly ancient organism, one that diverged from anything in our records before modern humans existed, those matches may not come. We have no immune memory for these things. Our bodies have never encountered them. Our children have never encountered them. Our great-great-grandparents, who gave us our current immunological inheritance, never encountered them. Whatever antibody responses the human immune system has built up over millennia means nothing against a pathogen that last circulated before Homo sapiens left Africa. That's the real vulnerability. Not just that these things exist, but that we'd be starting from zero. Now, I want to be honest with you about what I'm saying and what I'm not saying. I'm not claiming that the next pandemic will come from permafrost. Ancient pathogens locked in permafrost are real. Their survival over tens of thousands of years has been demonstrated. What the scientific evidence supports is this. Their ability to infect host cells after thawing has been demonstrated. The permafrost containing them is warming and thawing at an accelerating rate. And our systems for detecting and responding to truly novel biological threats are not designed with this risk in mind. That combination, real risk, demonstrated mechanism, accelerating conditions, insufficient preparation, is not a conspiracy theory. It's an engineering problem, one that nobody in a position of authority has been willing to put a name on. And maybe that's the most unsettling part of all of this. Not the viruses themselves, but the silence around them. When you go looking for serious scientific discussion of ancient pathogen risk, you find it. It's not hidden. It's published in journals, presented at conferences, cited in review papers. Virologists know about this, epidemiologists know about this, climate scientists know about this. But when you go looking for it in mainstream public health communication, in the kind of messaging that shapes policy, that determines research funding, it's almost completely absent. The WHO's pandemic preparedness frameworks run to hundreds of pages. Permafrost pathogens occupy a footnote at best. Major funding bodies allocate billions annually to surveillance of known zoonotic spillover, and a tiny fraction of that to understanding what's in the permafrost, less than a rounding error in the overall budget. Why? Partly because the permafrost risk doesn't fit neatly into existing institutional categories. It's not quite an environmental issue, not quite an infectious disease issue, not quite a climate issue. It lives at the intersection of all three, which means it tends to fall between the institutional gaps where those fields don't talk to each other. Partly because the timeline is uncertain. Scientists can say the risk is real. They can't say when or where or which specific organism. And in a world where public health resources are scarce and political attention is scarcer, uncertain timelines don't compete well against definite threats. Partly, and I think this is underappreciated because acknowledging this risk openly requires acknowledging something deeply uncomfortable. We have built our understanding of biological threats around the assumption that we know what's out there. But the permafrost is a catalog we've never opened. A library with the lights off in a building whose foundation is cracking. And instead of turning on the lights, we've been mostly pretending the building isn't there. So where does this leave us? The permafrost is thawing at rates that outpace most of the projections made even 10 years ago. The Arctic is warming 4 times faster than the global average. Regions in Siberia and northern Canada that have been continuously frozen for over 10,000 years are now experiencing summer thaws that reach depths never recorded in human history. Each of those thaw events releases whatever was stored at that depth. Research teams, small ones, underfunded, doing extraordinary work, are actively sampling permafrost cores and cataloging what they find. The work is slow, the scope is vast, and the gap between what's been sampled and what's out there is measured not in percentage points, but in orders of magnitude. If you want to do something with this information other than close the tab and try to forget it, the most useful thing is also the simplest. Pay attention to outbreak news with a different filter. When you read about an unusual cluster of disease in the Russian north, or northern Canada, or Alaska, ask the question that nobody in the official press release is asking. Ask where this came from, not which animal, which layer of ground. And maybe share this video with someone who you think would ask that question too, because the more people who know to ask it, the harder it becomes to keep the answer in a footnote. The horses that collapsed in that Siberian village in 1890 never got a real explanation. The people who died alongside them became a statistic in a regional health report that almost nobody has read. But the pattern they represent, the animal deaths, the human deaths, the official silence, that pattern has echoes across the entire last century if you know what to look for. I looked. And I'll tell you what unsettles me most after going through all of it. It's not the 48,000-year-old virus that came back to life in a French laboratory. It's not the anthrax that killed a child in Siberia after 75 years in the ice. It's not even the 13 new ancient viruses that barely made a single headline. It's this. Every one of those discoveries was made by a tiny team of scientists working on limited budgets in remote locations, sampling an infinitesimal fraction of the permafrost that exists. And in every single case, every single one, they found something alive. Every time anyone has gone looking, something has been there. We just haven't been looking very hard.